All right, let's jump right in. Today we're going to talk about something that makes a lot of people nervous: advanced math. We're going to explore this really interesting idea that the math that seems the most useless might actually be the most important tool we have for learning how to think. So, yeah, let's get into it.
I mean, come on. We've all been there, right? This is the question every student asks, every parent hears. It's the ultimate challenge to why we even bother with higher math. And you know what? It's a totally fair question. Why should we spend hours and hours struggling with something we're probably never ever going to use in our daily lives? Let's just take this equation right here. It's the formula for a circle. For almost all of us, this has zero practical application. You're not going to use it to do your taxes or cook dinner. It's pretty much the perfect poster child for what people call useless math. But let's flip this on its head for a second. What if we've been looking at this all wrong? What if the whole point isn't to memorize this specific formula for later use, but it's about the mental workout your brain gets just trying to understand it? This is the big idea we're digging into today. Math as a kind of mental whetstone, something that sharpens your mind. And this is not a new conversation. Not at all. This battle over what math is actually for has been raging in the world of education for well over 150 years. And it's always been these two completely different philosophies clashing with each other.
So, this pretty much lays out the two warring camps. On one side, back in the 19th century, you had this idea of mental discipline. They saw math as like weightlifting for the brain. The harder and more abstract it was, the more it strengthened your ability to reason. But then in the 20th century, you get this huge pushback saying, no, education should only teach practical, useful skills for the real world.
And this pushback got intense. I mean, look at this quote from a super influential educator, William Hurd Kilpatrick. He wasn't just saying that abstract math was a waste of time, he was arguing it could actually be harmful to the way you need to think in everyday life. So that really set the stage for a big question. Could the benefits of math actually transfer to other parts of your life? Okay, so let's get into the nitty-gritty. How exactly does wrestling with these weird abstract concepts in geometry and algebra actually build a better thinker? Well, it all comes down to learning how to build and navigate logical systems. Geometry is the perfect place to start. And really, it's not about triangles and circles. At its very core, geometry is a formal system for learning deductive logic. You start with just a few basic, unshakable truths, they're called axioms, and from that tiny foundation, you build this enormous, complex structure of truths, or theorems, using nothing but the pure rules of logic. I mean, think about the process of doing a proof. Every single little step has to be justified. You're building this airtight chain of logic. That rigorous step-by-step method, that is the real lesson. It's the exact same kind of thinking you need to write clean computer code, build a legal argument, or design a science experiment. You're basically learning how to build a perfect argument from the ground up. Now, let's switch gears to algebra. It usually starts with something really concrete, like this problem here. You learn a specific set of steps to solve for x. It's a useful skill, for sure, but it's limited. But then, algebra asks your brain to do something amazing, to make this huge cognitive leap. It wants you to see that the exact same procedure can solve this more general problem. And not just this one, but a whole class of problems that look like it. This is called schema induction. You're seeing the deep structure underneath. You're not just solving a problem anymore. You're learning a universal blueprint for how to solve problems. And that is the incredible power of abstraction. So, okay, the theory sounds great, but for like a century, the big question has always been, is there any actual scientific proof that this whole mental whetstone idea really works? Let's take a look at what modern cognitive science has to say about it. This is the million-dollar question, right? Does learning to think logically in math class actually make you a more logical person out in the real world? Because if those skills don't transfer, then that whole mental discipline argument kind of falls apart. And what's cool is that the evidence is getting clearer and clearer. It does transfer. Studies are showing that students with a lot of math training do better on logic puzzles that are specifically designed to trip up our natural cognitive biases. The key takeaway here is that math seems to act like a corrective lens, helping you override your flawed gut instincts with careful analytical thinking. But, and this is a really, really big but, it all depends on how the math is taught. If you just learn by memorizing formulas, what they call rote learning, those skills are going to stay locked inside the math classroom. The transfer only seems to happen when you learn conceptually, when you really understand the deep structures and relationships. That's what lets your brain take that skill and apply it to totally new situations.
And we actually have a pretty good idea of what teaching methods work best for this. It's not about speed drills. It's about encouraging what some call a creative struggle, where students have to invent their own solutions. It's about comparing lots of different examples to spot the underlying patterns. And maybe a little surprisingly, it's about deliberately making and learning from mistakes to build a much deeper, more solid understanding.
So we've covered the history, the theory, and the science. But why is this conversation so incredibly important right now? Well, because this whole debate is at the absolute center of a major crisis happening in education, one that's all about access and fairness. You may have heard of something called the calculus gatekeeper. For decades, the traditional high school math track, which ends in calculus, has been used as the main filter to decide who is college ready. And this is true even for students who are going into fields that will never, ever use calculus. It ends up being this huge bottleneck that can completely derail a student's future. And this is where it becomes a massive equity issue. Access to this mind-sharpening curriculum is deeply unequal. Just look at this chart. A full fifth of all Black students in the country go to a high school that doesn't even offer calculus. So if we're saying abstract math is this key tool for building advanced reasoning, then denying access to it is denying access to a fundamental kind of intellectual empowerment. This has kicked off a huge debate. Do we stick with the traditional calculus path, which, for all its problems, we know provides this deep, abstract rigor, or do we pivot to something that seems more relevant today, like data science? The big challenge is that while these new paths might be more practical, there's a real danger they might not provide that same foundational, transferable training in logic. And that brings us right back to where we started. After everything we've talked about, let's ask it one more time. What is the true value of learning this one seemingly useless equation? The answer is the goal was never about calculating points on a circle. The real skill, the meta skill, is learning how to take a messy piece of the real world and define it using a clean, abstract, logical system. It's a training exercise for your mind, getting it ready for any complex challenge that requires you to create order out of chaos. And so that leaves us with one final and I think really critical question. If we accept that abstract math is this incredibly powerful tool for training the human mind, then our most urgent task has to be figuring out how we make this mental whetstone not just sharp, but accessible to every single student. We need to ensure that the power to think deeply and logically becomes a right for everyone, not a privilege for the few. Thanks for watching.